In the last video, we established what Kafka is, the architecture behind it, and the basic workings of it. So, before me actually demonstrating on how it works, let me just show you the blueprint of how all of these things work. So, we have a producer here that produces or sends data to a given topic, and that topic is further divided into two partitions. So now this producer can send data to either partition 1 or partition 2, and these partition sends data to a consumer. So we have two consumers in a group. So when I send data from a producer to partition 1, that is further transmitted to consumer, and now each of these consumers have an associated WebSocket servers in them. So now when data comes to this consumer, that data is given to this server, and that WebSocket server transmits data to the front end, the client. So the client has two WebSocket instances that listen to each of these WebSocket server. So once data comes in to this WebSocket instance, that data we essentially inject it to a graph and we illustrate it. So now that we have a better understanding on what is going on here, let me actually demonstrate it. So let me open my terminal right here. Let me go here. So this is a producer, and the first parameter is the x-axis, the name here. So let me just say C, and the next one is the value. Let me say 54, and the last parameter is the partition on which I have to send it to. So let me say partition 0. Now if I hit this graph changes. Now let me do the same thing and give it to partition 1, and I'll change the value to 57. This changes. I can keep doing that, and this essentially streams data from the WebSocket through the WebSocket to the client, and 1, it changes. Let me do this one last time. So let me say D, and I'll give it to partition 0, and this changes. This is what we'll be building today, and by building this you will learn on how to implement streaming of data in your projects with Kafka and WebSockets. This video will be a continuation from where we left off from the previous video. So I'll leave this repo called Kafka Basics down the comment section below. So this is the code from which we will build upon, and I will also leave this as well. So this is the finalized version, which is called Kafka WebSocket JS. Once you have cloned the repo, this is how it will look like. So to start off, let's establish a basic structure. So we have a front end and back end. So I'll create a new folder called front end, and I'll also create a folder called back end. Once that is done, I'll just take in the source directory the package.json files and put it into our backend right here. So once that's done, we have our backend ready. So let us go into our backend here. Let's say cd backend. So once that's done, I'll just npm I everything. One second. Okay. So as we are using WebSockets, we'll also need to install a package for that. It's called npm iws. Once that's done, let's create another folder called service, and we'll move our Kafka client into this service folder. So yes, so once that's done, we'll create another file called websocket.js. Cool. So after this is done, we'll create one last file called index.js, which will have our express server. In here I already have a snippet that starts a express server for me. I'll just modify it and remove all the packages that is not required. I'll save this, go to package.json, make sure I have a dev script here, and I can see that I don't have an express dependency, so I'll install express here. Okay, so once that's done, let's just check whether our server is running and test it out. So listening on port, and it's not mentioned here, so I'll just say port is port 8080. So that should start here. Let me run it again, and you can see we have a basic server setup. Let us move on and create WebSocket servers for us so that we can associate them with our Kafka consumers. So let me import it. So now that we have imported it, let us create few instances of it. So I'll create a few. By few I mean two. So let me call it WSS1 and WSS2. This will run on port 8080 and port 8081. Now let me just create a function that starts these servers up. So this function basically starts both of these servers. So there's an event for WSS1 called connection, and I just console log out so that I know that this server is connected. I do the same for our second instances, and if there is an error, we also console log that out as well. So next, let me just export it now. Now let us move on to our index.js file again, and here I'll create a init function that basically starts up our WebSocket server. It creates a topic with the given number of partition in our admin.js file, and it'll also start up two consumers that listen to those two partitions. So let us do that now. So we have init. This will be an async function, and now we'll have to start or rather we'll have to initiate our admin.js file. So let us go here, and I'll say admin. I'll just modify this admin init, and I'll also export it. So export default admin init. I'll also make sure that I update this import. So this should be from the source directory service / Kafka client.js. I'll save that, and now I'll move on to my index.js file. I'll await admin init, and this should be admin.js. Now I will also start my WebSocket servers. I'll import it as well. So import it from here, and I'll save it. Now we'll have to create two consumers here. So let us start by modifying this right here. So let me start off by renaming this. So consumer run, and this will have three parameters coming in. So one is the group ID, the other one is the topics to which it has to subscribe to, and the other one is the WebSocket server. So in here I can just say group ID, and we can say connect subscribe to topics. I can just remove all of this and just say topics. So once that's done, so instead of doing it like so, what I can do is I can just cut this and say handle, let's call it message. Okay, so here what I'll do is I'll create a function called handle message. So this should work now, and I'll remove all this. So in here we will be getting certain things from Kafka, which is the topics, the partition, and also the message, which is coming in from the producer. So in here what I can do is the WebSocket server, I will transmit the data coming in, the message, to all the clients subscribed to this particular WebSocket server. So for that, it's wss.clients dot for each of the client, and if the client is only ready, then only we'll send the data in. So ready state is equal to 1, which basically means it's open. So then what I'll do is client dot send. I'll send in the message that is coming in from our producer. That should do it. And let me wrap this in a try catch just to be safe. So I'll take this and cut it here, paste it right here, and I'll also say here console dot error, the error message. I'll make sure that this is imported from the service folder Kafka client.js, and I'll also export default this. So I'll say export default consumer run. I'll save everything. I will also add a console log right here so that I know what is coming in. So this should be a topic, yeah, so that I know this handle message is working correctly. So this is just for debugging purposes. If you're deploying, you would probably just take it all together out. So once that's done, I'll just call that function here. So await consumer run, and I'll say this right here. So this is consumer, this is the group ID. So I'll say instead of this, it'll be real time, let's say real time data, the same thing. And here it's given app. So instead of app, I'll use WSS1, which is basically the first WebSocket server, and then the second one, WebSocket server 2. And this is not yet imported, so I'll import it. Okay, I wonder what's wrong with my imports. So let me import it manually here. Consumer, that should do it. And lastly, I'll make sure I call this function right here. So with that, our basic express is done. So the last thing which we would need is to change our producer right here. So in here, let us start doing that. So first off, again, we'll have to import Kafka client from service Kafka client.js. I'll also change the name of this to producer run. Same here, producer run. So in the demo, you all saw that I was hitting some prompts in the terminal, and that used to produce data. So for that, we will make use of a package called readline of Node, which will basically allow us to produce data and give it to the consumers. So that's what this will help us in. Once we have defined a RL instance of the readline.create interface, we can start interacting with our terminal. So we'll set the prompt to enter prompt, and we'll also start the interactivity with the dot prompt method. So now in here we have a listener called rl.onLine. So after each line, what should happen, right? So here I'll have a callback function called line. So this will give us access to the properties which was typed in by the user. Now what we can do is we can destructure that string with name, value, and partition. This will be given us by the line.split method. And after each, so if the user types in something like hello, so let me just hello 04. So this dot split method, what it does is it takes the string, breaks it apart in this space. So hello will be one, 0 will be another string, and 4 will be another string. So we are basically destructuring that array. This gives us an array of those strings. So once that's done, what I can do is I'll move this entire function into this rl.onLine method, and here what I can do is the partition will be parse int, make sure it's an integer, and I'll give it the partition. So I can remove the key here, and for the value I'll just give in this value right here. So I'll say value, and I can also remove this. I can save everything. So I want to actually send in name and value together to the client. So in order to do that, I'll have to stringify this JSON object. So for that, I'll do is JSON dot stringify, and then I could just do something like this. I'll save everything. Next up, I will disconnect the producer on the close event of RL. So in order to do that, I'll just take this, I'll do this right here. So on close, we disconnect the producer. So I think with that we are done. I'll save everything. So let me just double check this. Okay, so everything seems to be correct here. So with that, we have actually done the backend portion of the video. So next up, we'll have to configure our front end. So let's do that. So in here, let me quit this and go to, I'll cd one step back, go to front end. Now I'll create a next app here. With that, we have our next server running right here. I also removed the ESLinting by deleting that file. So now we can start working with the front end. So the other thing which we'll need is, we'll need to install a package for the charts called recharts. Since we are dealing with WebSockets, instead of relying on a third-party package for subscribing to the WebSocket, I decided to create a custom hook for that. So let us do that now. So let me actually create a folder called, first one is components, that will hold our charts, and the other one is the utils folder. So under that, we'll have a hooks folder. So inside the hooks, I'll create a new file called use ws.js. So this will be our custom hook. So in here, let's start off by saying RAFC. So here I'll need a couple of states. I'll just save this. I'll make sure I import use state. So use state. I'll also need use effect. I also need use ref. Cool. So this state will be responsible for checking whether the socket is ready. So only if it's connected, then we'll start the process. And this state is responsible for holding the value sent by the server. So the other thing which we need is a ref for the WebSocket. So for that, we'll use ref, and I'll say the initial state is null. So now let us have a use effect. So this use effect will subscribe to the WebSocket API. So let us create an instance of that, ws instance. So this WebSocket requires a URL. So that is what we'll be sending through a prop. So I'll say URL, and I'll give it the URL here. So once we have created an instance, let's start by adding some event listeners. So on open, let us just give a callback and say set is ready to true. So this is the first event listener. Now the second one will be on message. So if a message is sent from the server, we'll hold it using a state. So let's say set value to message.data. So once that's done, I'll have another last event listener called on error. On error, we'll just console log out the error. So once that's done, we will say ws current, which is the ref, and we'll assign ws instance to it. So after that's done, since we are subscribing to a web API, it is always good idea to clean it up to avoid leakage of data. So I'll just say w instance dot close, and then also say set is ready to false, and this use effect should run only when the URL changes, right? So once that's done, I will say return the is ready state, the value, and we won't be using this, but in case you want to send data to it, let us create a function for that as well. So I'll say send, and inside this we'll have a data. We'll say if ws dot current ready state, so only if the state is open, the WebSocket is open, we will use the send function of the WebSocket to send data to the backend. Else we can just console the error out, so just say WebSocket not ready, that's fine, and else also use the send function right here. Cool. So with that, we have a custom hook available to us that subscribes to that WebSocket. So let us go back here. In here, let us create some states which is required. So just for demonstration purposes, I won't be using Next.js features. So instead of server-side rendering, I'll just client-side render it out, because that's not the point of this video. You could just make a few structural changes and it would work fine in Next.js. Now let me make sure I import everything here. So I'm basically importing the use.ws custom hook that we just created. I'm passing in the URL and it should subscribe to it. So now let me create a use effect. So inside the use effect, we have the is ready property, which basically checks whether we have the whether the socket is ready. So if in case it's ready, what I'll do is I'll say console log client 1 connected. I can remove this. Okay, so now if we have this value which is coming in from the WebSocket ws1 value, so if I go back here, you can see if there's a message coming in from the backend, this set value will be occupied. So the value will be, there'll be something in this value state. So that's what I'm checking here. ws1 value, if it's there, then what I can do is I'll destructure two things from it, which will be the name, the value. So if I go back to my backend right here, and if I go to producer.js, you can see that the first is the name, whatever the x-axis of the graph is, and the value, the number, will be sent. Partition is just to send the data to partition 1 or 2. So I'll have these two properties, name, value. So what I'll do is I'll destructure name and value out, and because it is stringified in the backend, I'll have to parse it. Then what I'll do is I'll set my, so this state will hold an array of these values. So what I'll do is set ws1, I'll access the previous value. So since this is an array, what I can do is I can spread the prev. Then what I'll do is I'll inject in that object name and value, but because value is a string and I want a integer, what I can do is I'll assign it, I'll say parse int, and I'll give it the value. This is just because the value coming in from the backend is a string and I want it in integer format, because else the graph won't reflect the changes. I had the same problem. So when the data was coming in from the backend, it was a string and the graph was not getting populated by it was getting populated, but it was not showing up in the graph because this was a string. So that's why I'm making sure it's an integer. Okay, so the dependency array will have w, we'll check whether this is ready. It should change only when this is ready, and ws1 value. So this is for the WebSocket 1. So I'll do the same thing now for WebSocket 2. I can do this. I can just change all of this. Save it. Now I'll run the server. Now we can start testing out our application. So before testing it out, if you remember in the first video, I demonstrated how to actually start our Kafka instance. So you'll have to put your IP address. So what we can do is, I'll just clear this out and just type in ifconfig en0. This will give you your IP address, and I can just take this and paste it right here. Save it. I'll close this. Now what I'll do is, I'll go back here. Let me create another window. So this will help us. Okay, so this is a window right here. What I'll do is, because we'll be working with multiple instances of the terminal, I'll create one right here. So in case you're all wondering, warp is just like a superset for the terminal. The terminal works fine, but this gives you suggestions, etc. So I just chose that instead. So let me go where my project lies. So it lies here, Kafka basics. So in here, I'll say docker compose up. See, as you can see, it just gave me a suggestion. That's why I chose warp. So let this start. So now let me go to my backend here, cd backend, and I'll say npm run dev. So if we didn't do any, okay, so we have some errors. The request model does not have an WebSocket server. Okay, so we made an error right here. Let me close all the open editors, minimize the front end, go to our WebSocket right here, and probably the mistake is this one, and I'll just update all of this. Cool. I'll save that. I'll try to rerun our server now. We still made a mistake. Let's see. So I can see I've misspelled it again. It's soccer. It should be socket. Probably should go out and play more. Socket. Save it. Please let me see whether I embarrass myself again. Okay, I did. Let's see where the problem lies. Use 8080. Okay, I probably know what this error is about. So as you can see, we are already using port 8080 and port 8081. So if I go to my index.js, I'm probably using that again. So I'll use 8000 instead. Let me run the server again. Cool. Okay, so with this, I believe our backend is working. Create a new instance right here. Go back one directory, cd into front end, and I'll run our front end right here. Let this run. Let me go here and say localhost 3000. So you can see client 1 connected, client 1 connected. This is probably an issue with the consoles. So let me go to front end, go to app, go to page.js, and I'm probably doing it right here. See, so client 2 connected. Make sure this is also correct. 1 2. Oh, cool. So let me refresh this again. You can see client 1 is connected, client 2 is also connected. And if I go to my backend here, let me just, you can see server 1 is also connected, server 2 is connected. So everything probably is working just fine. So now what we can do is we can start producing our data. So let me create a new window of this terminal. So let me just resize this. Again, I'll go cd one directory up, cd to our backend, cd back end. So what we are going to do now is, I'll just close everything here. So I'll just run this producer right here. So with node producer.js, I'll run this so that now we can start producing data. So I'll say node src producer.js. enter prompt. So let me say the name is a, value is 10, and partition 0. Let me open this as well. So this is the backend. You can see these are the console logs of the consumer. So here, if you remember, we've console logged it out. So topic is Thabish topic, partition is 0, message is A10. And okay, I'll try A10 1, and you can see partition is 1. Now what I can do is I can actually go back here, go to a front end, and I'll start console logging out our data. So ws1 data, and I'll say ws2 data. I'll save this. Now let me go back here. You can start seeing the logs here. Let me refresh it so that, okay, so you can see it's both are empty. So let me do that again. So A10 0, partition 0, A20 1, partition 1, and if I check right here, our ws1 data is a, value is 10, ws2 data is a, value is 20, fine. So everything is working. So then now the last step would be to just add charts to this. So that's pretty straightforward. I'll do that. Let me go to front end, go to components, and in here let me create a new file called area chart canvas.js. I will just paste in the code right here. This is just to save time because this is just UI part, simple UI part. With the recharts, we are just importing some components that gives us that graph, and as props we'll be sending in the data which is coming, the ws1 data and ws2 data, and also the color. So I'll save this. Now I can go back to page.js right here, and instead of this I'll just paste in that right here. I'll import this and I'll save this. You can see for this prop ws1 data, I'm sending it to the first area line chart canvas, and also the color, and here as well. So now if I can start seeing something right here. So let me refresh this. Let me actually bring in my producer right here. So let me go here. Okay, now let me restart this just in case. I'll say for the x-axis the name is A66 0, A77, partition 1. You can see that starting to show something here. Again, B45 54 0, B50, no, let me go as 99 1. You can see now we are getting in the data. So with this we've learned how to stream data using WebSockets and Kafka. If you've got any good ideas on what projects we can build further with this, please let me know down the comment section below, and if you have any constructive criticism also, please let me know. So this time around I actually started typing in everything. So if you want a more concise video on me actually filtering out all the errors that I make, let me know. Thanks for watching. See you guys in the next video.